Welcome. In this video, we're going to talk about sets, a data structure that is not linear for the first time. So, what's a set? A set can be thought of as a mathematical concept. So, for example, in math, we can have sets of different elements, but in general, you can think of it as a bag of unsorted elements, and in which every element can only be contained once. A very important part of sets is that they cannot only contain elements that are hashable. So we are talking about the basic data types of Python, for example, numeric values, strings, tuples, but ordered and unordered data structures, such as lists and dictionaries, are not hashable. So, for example, we can see that we can create a set with the set constructor down here, and we can pass it as an argument any iterable object. And what does iterable mean? That we can go through it and extract its elements. For example, in this case, with the string hello world, we can extract from it the characters that form it. So when we print the set produced by the hello world set instruction, we get the letters that form the set, the word hello world, without repetition. So the O appears only once, and the L appears only once instead of thrice. Sets have many methods, but the main basic ones are these. We have the length that returns the number of elements in a set. We have the in operation, an element belongs to the set, so the element appears in the set C, and it returns a Boolean value. For example, we can see that H appears in the hello world set, but A does not appear. We can also add elements to the set with the add operation and remove them with the remove operation. There's also a discard operation that's very similar to remove. The difference is that if you try to remove an element that is not present, then you'll get an error. But if you try to discard it, then it will not cause any errors, even if the letter does not appear. So, for example, if we tried to remove H, that works because H appeared in the set, and then we can discard D. But if we try to perform those operations again with the final set we have down below, the remove operation would cause a key error, but the discard operation would just do nothing and wait for us to continue. We can also use the pop operation to obtain any element from the set, because the delete operation needs you to pass an argument to it. So, for example, you want to remove the H specifically. To say remove any element from the set and pass it to me, we use the pop operation. We can also clear the set completely and go back to a full empty set, or copy it. It's very important to remember that because sets are objects, every time we assign a set to a new variable, we're not making a copy, we're referencing the same set. So if we create a set, for example, hello world, and then assign it to a new variable and delete one of the letters, for example, L, both sets would be affected because they are actually the same set. If instead we copy it, we can remove the elements from one of them. For example, we can clear the contents from S and then print both, and only S has been affected because A is a copy of S instead of just the same set. We can also use the classic operations in math, which are is subset, lower than, is superset, and greater than. And this checks whether the elements are contained within each other. So, for example, the set ABC is a superset of BC because it contains all elements from BC and additional ones. And we can liken these operations to math comparisons between numbers. You always have to remember that just because a set is a subset of another, isn't a subset of another, doesn't mean that it will be a superset. And we can also use union, intersection, and difference operations. So, for example, a union is equivalent to adding all the elements from a set to a larger set. We can also use the intersection, which means finding the common elements in multiple sets. And we can do so with the union or intersection methods, or we can also use the operators bar and ampersand. Finally, we can compute the difference between sets, which means finding which elements do not appear, removing elements from a set that appear in a second set. And always, of course, we can concatenate these instructions to include multiple sets. So for example, we can perform the union of A, B, and C, or the intersection of A, B, and C, and so on and so forth. Finally, we also have the symmetric difference, which means finding the elements that are unique in each of the sets. So this is the opposite of the intersection of two sets. And it also has a specific operator, in this case the circumflex accent, to signal instead of using the full method name. But this is always an option. You can choose whatever you want. Finally, if you want to make a set immutable, so if you want to guarantee that no one is going to touch the set that you're giving them, you can use the frozen set constructor, and then you will create a set that cannot be altered, and thus no one can remove or add elements to the set. And this is all. I'll see you on the next video.